So we begin our dive by looking at turret control, as we said, and this is going to be definitely the most complex of our scripts that are associated with the gun. The reason for its complexity is because, as I noted before, the main function of the turret control script itself, which is attached to the gun base, it could have been called gun base control, but I could also call this turret, since it's the thing that turns along the y-axis. Its main function is simply to rotate the whole gun assembly around along the y-axis. However, in order to do that, it needs to have the full logic for how to aim the gun at the target and how to estimate where the target is actually going to be by the time the shell gets there. And since all the logic has to be in this script anyway, I have simply put it in there and then allowed the other objects to take advantage of that calculation rather than having to do them again. So we will see that in subsequent videos. So all of my scripts are in C#. That is just by my preference. And I am certain that you could do all of the same thing in JavaScript, the other programming language allowed within Unity3D, but I'm more comfortable with C#. So, as with any new C# script created inside Unity3D, you've got these libraries automatically imported, Unity Engine and system.collections. We don't need any additional libraries like UI library or any of the other ones for this, or really for any of the other scripts. The script must be attached to gun base. It's always a good idea to label these, even if you're the only one who's using the script. Certainly if you think other people might be. So I've called this turret control. So let's see the variables that we're declaring. First two, just this transform and root transform, are just going to be this dot transform and root dot transform. Then we have a couple of vector threes, actually a series of them. Target position is going to be where the target, once we've acquired it, where it is at any given moment of runtime when the gun is trying to make its aiming calculation. Estimated target position is going to be where this logic below calculates the target is going to be by the time the shell actually gets to the target where it's supposed to be, based on the target's current position in world space and direction and velocity. So there's some complexity to that. And that's why we need to know what the target velocity is, we need to know what the target direction is, and then updated direction goes along with estimated target. Or actually, direction is simply a vector between where the gun is and where the target currently is, and here's where the vector between where the gun is and where we think the target's going to be. My opponent is the actual target. Now notice that I've made most of these things public game objects, which has the effect, if we look at turret control here, of exposing all of these in the inspector. And it would be possible, since we know that my opponent is going to be this player jet, I could simply drop the player jet object right there into my opponent slot, and then I'd have a reference to it. However, I've learned it's best practice not to do this, but instead to acquire it at runtime. And the reason is because in many more complex games, you may have any number of opponents, and you'll need to acquire them as different targets at different times based on their current state or how close they are to you or something like that. So when possible, I try not to set objects in advance in the inspector if there's any chance that they're going to change during runtime. And of course, all these other things are visible in the inspector, but it would be entirely unreasonable to try to set them in advance. The reason that I've got them as public, including my opponent itself, is simply for debugging purposes. So that, well, it just, because I tried to take off too fast. Let's try that again. You can already see that it's acquired the target and is calculating its position, but we'll go ahead and plane take off, reach an altitude where the gun starts firing. Now I can pause it. And the reason that I've made these public, well, there's actually two reasons. One of them is so that I can view them in the inspector and ascertain, yes, we've acquired the target, the player jet, at runtime. And I can also look at the target position and verify that against the actual position in the world space of where the player jet is at this moment. It's out there somewhere. And I can also look at the estimated target position. In other words, the math that it's using to estimate where it thinks it's supposed to be when the shell goes off, and sort of see how that compares to where the target actually is and how well my math is working. Now, that's one reason to expose all of these things in the inspector, in other words, to make them public. The other reason to do that is because I am going to have all of those properties also used by the gun control, which is the script that controls the aiming for the guns themselves. And in order to do that, they have to be public properties. So the last one here is bullet velocity 2000. This represents meters per second. Meters are the sort of standard unit of measure in Unity if you don't set it as something else, and I've kept it at meters. And 2,000 meters a second is a reasonable velocity for Second World War anti-aircraft. So on start, I'm just setting this transform, this dot transform, this transform root. And then here is where I'm acquiring my opponent. There's only one object with a player tag, and so that's going to be my opponent. I can go ahead and grab that right when we start. Now, after that, there's two main functions. One of them is the update, and the other one is this calculation, which is quite complex, of first order intercept time.